Now you can hear. Hello, Arian. Long time no see. How's it going? I had my other microphone set. Exams? Fun. Try the most toxic game? What are you talking about? Right. I think it's set up. Also, Rust? I have no clue. Do you think I am playing Rust? I'm not playing Rust. I'm using Rust. Rust is a programming language. But yeah. No, Rust seems good, but I have never tried it, so I'm gonna try it because I have to switch from Unity. No, not you. The other guy on YouTube that you can't see. Alright, so I just have a tutorial that I'm gonna follow. We'll see.
Alright, perfect.
Blue, so the blue screen is just Visual Studio PowerShell. It's basically like on prompt.
If we look in our cargo toml file, you'll see that we have...
Right, you have to do cargo. So do I just type cargo bevy?
Have the bevy perfect. And to do that, let's go ahead and add bevy.
Cargo add bevy. Fuck you. See, this is why I hate programmers, especially
perfect. So if we look
Linux users. Like, what the fuck are you talking about?
to navigate to the project in my integrated terminal here. That way, when I have to use the terminal, I don't have to bounce back and forth between different apps. Okay, so now that we've got our project created, let's go ahead and install the Bevy game engine.
No, he's not using Linux. This is Windows.
To do that, we're going to use cargo app.
So how can I not use that there? Cargo add bevy. What the fuck? What are you talking about? Package managers. Several Linux distributions package Rust, and you may wish to use the package toolchain, such as blah 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 blah. Add that directory. Okay. So dot cargo bin cargo. Did that not get added? Like, what the fuck is he talking about? Advanced system settings. Environment variables. Cargo bin. It's right there, bitch. Is it because it's not down here? Could not find cargo.toml. Cargo new project. I think I made the project in the wrong way. Hmm. You call this basic usage? It doesn't tell me anything. It literally does not tell me how to use it at all. How do I use it? How do I use it? This is why I like Unity, because I don't have to deal with programmers. Read the book. Yeah, that just puts me here. Fuck you. This is different. This is another section. Hello, Ian. Hello, world. Okay, so it's because I've made a C++ project. Repos. Rust test project 2. So what am I doing? I'm trying to figure out how Rust works, and Rust is a programming language. What is the... How do you open PowerShell? Windows command for PowerShell. It's just PowerShell, I guess. PowerShell. Yeah, okay. Yeah, okay, yeah, it's the same. I don't know if I should use the Windows PowerShell. Probably. Alright, so we made it there. Next, make a source file. Rust files always end with the .rs extension. If you're using more than one word in your file name, the convention is to use an underscore to separate them. Why? I guess. So how do you PowerShell make file? New item. App. Main dot. Is it RS? This work? Item type file. No, it says new dash item. There, now we have a main.rs. Do I have a solution here already? Regardless. I don't know if I need Visual Studio Code or... No, I don't think so. Visual Studio 2022. Huh? Oh, I went into the wrong folder. Then we do the same thing again there. That's why there was a solution file there, because it was the wrong folder. Get rid of the old one. Wait. Fucking up big time. There we go. Now we got the main.rs there. Pop that open here. And then we're supposed to type fn main print line exclamation point hello world. And then to compile it, we say rust c main.rs run main. It says hello world. All right. Was easy. Let's review this hello world program. Here's the first piece of the puzzle. Fn main. These lines define a function named main. The main function is special. It is always the first code that runs in every executable Rust program. Here the first line declares a function named main that has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. Yeah. Function is wrapped in brackets. Rust requires curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration. Fuck off. Body of the main function holds the following code. Print line hello world. This line does all the work in this little program. It prints text to the screen. There are 4 important details to notice here. First, Rust style is to indent with 4 spaces, not a tab. Fuck off. Second, I hate this. Like, this is so annoying. But sure, I get it. Second, print line exclamation mark calls a Rust macro. If it had called a function instead, it would be entered as print line without the exclamation point. We'll discuss Rust macros in more detail in chapter 19. For now, you just need to know that using an exclamation mark means that you're using a macro instead of a normal function, and that macros don't always follow the same rules as functions. Third, you see the hello world string. We pass this string as an argument to print line, and the string is printed on the screen. Fourth, we end the line with a semicolon, which indicates that this expression is over, and the next one is ready to begin. Yep. Compiling and running are separate steps. You've just run a newly created program, so let's examine each step in the process. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command and passing it the name of your source file like this. If you have a C or C++ background, you'll notice that this is familiar to GCC or CLang. After compiling successfully, Rust outputs a binary executable. Yep. Okay. Hello Cargo. Cargo is Rust's build system and package manager. Most Rustaceans use this tool to manage their Rust projects because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. The simplest Rust programs, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you'll add dependencies, and if you start a project using Cargo, adding dependencies will be much easier to do. Pour some coffee. Because the vast majority of Rust projects use Cargo, the rest of this book assumes that you're using Cargo too. Cargo comes installed with Rust, if you use the official installers discussed in the installation section. If you install Rust through some other means, check whether Cargo is installed by entering the following in your terminal. Cargo version. Cargo version. You have Cargo. If you see a version number, you have it. If you see an error, you don't have it. Creating a project with Cargo. Let's create a new project using Cargo and look at how it differs from our original Hello World project. Navigate back to your project's directory or wherever you decided to store your code. Then on any operating system, run the following. Okay. So we type cd dot cargo new hello underscore cargo. Created binary application hello cargo package. cd hello cargo. First command creates a new directory and project called hello cargo. We've named our project Hello Cargo, and Cargo creates its files in a directory of the same name. Go into the Hello Cargo directory and list the files. Yeah, there's the cargo.toml. It also has initialized a new Git repository along with a gitignore file. Git files won't be generated if you run Cargo new within an existing Git repository. You can override this behavior by using cargo new dash vcs equals git. Yeah, Git is a common version control system. I fucking hate Git so much. Hello Cargo. Pop it open in Visual Studio. Yep, there we got the thing. This file is the TOML, Tom's Obvious Minimal Language Format, which is Cargo's configuration format. The first line, package, is the second heading that indicates that the following statements are configuring a package. As we add more information to this file, we'll add other sections. The next 3 lines set the configuration information Cargo needs to compile your program. The name, the version, and the addition of Rust to use. We'll talk about the addition key in Appendix E. The last line, dependencies, is the start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. We don't need any other crates for this project, but we will in the first project in Chapter 2. So we'll use this dependencies section then. Now open src/main.rs and take a look. Cargo has generated a Hello World program for you. Also, let me change RS files from GIMP to Visual Studio. Not Visual Studio version selector. Come on, bro. Microsoft Visual Studio. Maybe it is supposed to use the Version selector. Yeah, okay, that does work. Didn't set it as default though. However, it opens up a new one every single time, which is kind of shit, but we'll figure this out. Cargo expects your source files to live inside the SRC directory. The top level project directory is just for README files, license information, configuration files, and anything else not related to your code. Using Cargo helps you organize your projects. There's a place for everything and everything is in its place. If you started a project that doesn't use Cargo and we did the Hello World project, you can convert it to a project that does use Cargo. Yeah. Now let's look at what's different when we build and run the Hello World program with Cargo. From your Hello Cargo directory, build your project by entering the following. Cargo build. This command creates an executable file in target/debug/hello cargo. Yeah, there it is. Hello cargo.exe. If all goes well, Hello World should print to the terminal. Running Cargo build for the first time also causes Cargo to create a new file at the top level, cargo.lock. This file keeps track of the exact versions of dependencies in your project. This project doesn't have dependencies, so the file is a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. We just built a project with Cargo build and ran it with Hello Cargo, but we can also use Cargo run to compile the code and then run the resultant executable all in one command. Okay. Notice that this time we didn't see output indicating that Cargo was compiling Hello Cargo. Cargo figured out that the files hadn't changed, so it didn't rebuild but just ran the binary. If you had modified your source code, Cargo would have rebuilt the project before running it and you would have seen this output. Okay. Cargo also provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Okay. When your project is finally ready for release, you can use cargo build release to compile it with optimizations. This command will create an executable in target/release instead of target/debug. The optimizations make your Rust code run faster, but turning them on lengthens the time it takes for your program to compile. This is why there are two different profiles, one for development, when you want to rebuild quickly and often, and another for building the final program you'll give to a user that won't be rebuilt repeatedly and that will run as fast as possible. If you're benchmarking your code's running time, be sure to run cargo build-release and benchmark with the executable in target/release. Cargo as convention. With simple projects, Cargo doesn't provide a lot of value over just using Rust C, but it will prove its worth as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let Cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you'll use in the rest of your Rust career. In fact, to work on any existing projects, you can use the following commands to check out the code using git, change to that project's directory, and build. Bye. Alright, so. Can we get this shit to work now?
Add Bevy.
Then let's go out. Cargo new third person tutorial. cd third person tutorial. Cargo add Bevy. There we go. Finally, we are on track. And now I'm gonna use this little tutorial here. And I'm just gonna follow along, as I always recommend people to do.
Use cargo add Bevy. Alright, perfect. So if we look in our cargo TOML file, you'll see that we have the Bevy game engine crate right here, 0.11, which is the latest version as of this recording.
Without it echoing so much.
Alright, now I'm just gonna go ahead and build.
How do you open? Do I just type in the file? Let's see. Yeah. Yeah, looks good.
Build, or we should go ahead and build this project now, since we've added a new crate, and this will take a couple minutes. And in the meantime, we can.
What did he type?
All right, now I'm just gonna go ahead and build, or we should go ahead and build.
Okay.
This project now, since we've added a new crate, and this will take a couple minutes. And in the meantime, we can start adding some boilerplate code here. First things first, we need to.
All right. Let's dump all of this shit here. Third person tutorial, src, main rs.
Import the Bevy prelude.
Use Bevy.
Just like so. So now we can get rid of this hello world statement, and then here's just some more boilerplate code, and we're gonna add the default plugins. The default plugins adds things like the window that our game will be running on. I'm honestly not too sure what else it adds, but I'm sure you could dive into that, and there's probably a long list of default plugins that it adds. So let's take a look at that. Looks like it's finished. Just to make sure nothing's going wrong, I'm going to go ahead and just run it with cargo R. And we should just get a blank window here. Yep, blank window. And
Well. Yep, blank window. It's already handling Windows.
I still have MSI Afterburner up, so I'm gonna go ahead and get rid of that. So that doesn't.
That's why he had an FPS meter.
All right, very cool. Now we can go ahead and write our first system. So we're going to first create a floor that the player will be standing on and running around on. So I'm going to create a new system called spawn floor. And we're going to need a few different parameters here. First, we need our commands. That's going to actually spawn this entity into the world. Then we need meshes. This will control things like what the object will look like, if we want a square or a sphere or a cylinder, things of that sort. And that's just a resource just like so. And then we need one more resource called materials, and this will be in control of how that mesh is going to look, so what color it'll have and so forth. All right. So we're going to create the floor object here. I personally like to store it in a variable first and then spawn it with commands. I just think it looks
easier. I probably did. I thought that was good.
But you can skip the whole assignment if you want and just write commands.spawn and write everything inside of here. So
I think there should be a color.
My personal preference. And we're going to use a PBR bundle, and then we're going to have the mesh right here. So mesh.add. This is a little robust here, but just bear with me. So this is kind of like the constructor right here. And then now let's go ahead and give it a color. I think I wrote that wrong. There we go. Now let's add a color with the materials. And I'm going to make mine dark green, so it'll be sort of like a somewhat of a grass, if you will. And then we need to finish it off with the default parameters here, or default settings. And now you can use the commands parameter to spawn the floor, just like so. And okay, yep. Now we can go ahead and add this system to the main function. And to do it, we're going to write add systems, and then this will be a startup system, so it's only going to run one time at the startup. And then you can go ahead and specify the system right there. Okay, so let's go ahead and run it just to get a proof of life here. And we didn't get any errors, that's great, but you'll notice it's still a blank screen. And that's because there's no camera that we've spawned yet into the world, so it doesn't matter what you put into the world. If you don't have a camera, then it's not going to, you're not going to see anything. It's going to be a black screen like this every time. So with that being said, let's go ahead and spawn a camera. And I'm going to also put this in its own function. I just like to break my functionality out as much as possible. But we're going to call this one spawn camera. This one will be a little easier. We only need one parameter, and that's the commands. And then let's go ahead and store the camera 3D bundle into its own variable, just like we did with the floor. And we need to give this a transform, so it's starting position here. From X, Y, Z, so it'll be a vec3. And I kind of have these values calculated already, so sometimes it takes a little bit of playing around with to be able to get it to focus on like the floor exactly how you want it to. But this is, if you follow along with this, it should be just fine. And then it's going to be looking at this location right here. And then finish it off with the default settings, and then use the commands to spawn it. Again, we need to add this to our startup, and we need to wrap this in a tuple since there's more than one system. And let's go ahead and run this and see if we can actually see something.
Hold on. The startup, spawn floor, spawn camera.
This time. Oh, let's see. Transform, undeclared. Use of undeclared type, transform. What did I do?
Hooked up.
Oh, transform. Transform. I don't have my Rust analyzer.
Let's see. I didn't misspell that, so else what did I fuck up? I see it. There. Try again. Now we have a floor. Okay. Okay, okay.
Extension installed because there's a lot of pop-ups in IntelliSense when I'm typing, and I figured it might be distracting, but I might enable that for the next tutorial just so we don't run into issues like this. All right, now let's go ahead and run it. And there we go. Okay, so you can see the floor, but it's kind of dark if you notice, and that's because we don't have a light source at all. So the next thing we're gonna do is create a light. Let's create one more system called spawn light. And I think
Now, doing a tutorial like this, it doesn't it doesn't necessarily teach you how to do anything. Like it does, but at the same time, after you're done with this and you just sit down and you try to do it yourself, you're gonna be like I still have no clue. But going through something like this, it gives you like a bit of context, like contextual knowledge. Like you've seen how somebody like created a floor and spawned a light and spawned a camera, etc. And from there, it's a lot easier to start figuring out how to do it yourself, even if you have to do it, you know, still like crawling. I still think it's good to do something like this to go through a project so that you get some level of just context.
Yep, we only need the commands parameter for this one as well. I'm going to use a point light. Give it an intensity of 2000. That should do. Might be overkill. And then let's also give it a transform. And I just want it to sit basically on top, like floating above directly center mass of the floor that we have. So I'm going to keep the X and Z values at 0 and just put the Y value at 5. So it should just be floating right above the floor. Okay, now let's add this to our startup systems here. Cool, let's run it one more time. Okay, perfect. Now you can actually see the floor a little bit better on this one. Now let's create.
There we go, we got some light.
Create a player object, and to start with, we're just gonna.
Also, I'm not gonna really use any of the things that we're using here. That's the thing I have to make. I've already made all of it myself, so I just need to figure out how the language works really, so I can start porting things.
Square, a cube, and then later on you can download the. I'll have a link to a player object that you can actually download, or you can make your own, whatever you want. And it'll be a little bit more realistic in the sense that it'll have like a front and a back, so the front will rotate according to where the camera and direction that you're moving is. So if you have a cube, it kind of everything looks symmetrical. All right, let's create the spawn player function. And for this one, we need the commands. We're actually going to need all of these, just like the floor, because it's going to be very similar to the floor. So I'm just going to steal them straight.
And I prefer that. Unless it gets like giga long. I prefer this, I think. For what mut means. It's mutable. I never really understood what mutable means.
Straight from the floor there.
Changeable or something like that, I think.
And then also it's going to be similar to... Oh, no, not that similar. I won't copy it. We'll just make it from scratch here. Alright, so player equals PBR bundle meshes dot add mesh from shape cube this time, and we'll give it a dimensions of 1 by 1. And then let's go ahead and give it a color as well. I think I'm going to make mine blue. Oops. Okay, there we go. And then also a transform to give it a starting position. And I'm going to make it at 0.5. Actually, I'll make it at 0 so that way you can see why I do want it at 0.5. So we'll run it twice here in just a second. And go ahead and add it to the startup functions or systems. And let's run it. Okay, so here's the player, and you can see the camera's looking directly at it, which is great. But it doesn't look like it's a complete cube. It's more of like a rectangle, right? And that's because we have the starting position right... Where is it? Right here at 0. And it's a 1. The unit of measurement is 1 for the dimensions of the square. So only half of it is sticking above and half of it is sticking below. That's because of it's relative to the, well, it's not relative, but it's just interfering with where the floor is at right now. So to fix that, we're gonna make this 0.5, run it one more time, and you'll see that it'll look like it's sitting directly on top of the floor. Perfect. Okay, so that's it for the first tutorial. In the next tutorial, we're actually going to break this code up into different files a little bit just to keep our organization cleaner the farther along we go and the more code we add. All right, see you in the next one.
Okay.
All right, in this video, none of our logic or anything like that is going to change. We're simply just going to break our current systems into their own files and so forth to keep things organized. So all the camera logic, it's going to go into its own.
Let me got Git open there, but where's the solution? Browser. This doesn't count as a solution, so object browser. I just want to view my files. That too much to ask of Visual Studio? Server Explorer. bookmark window. Object browser. I'll be honest, I fucking hate Visual Studio. It's so like over bloated with functions, but at the same time it doesn't have anything that I want. It's so weird. Show all files. No? See if this works. The way I want it to. I literally just want a file browser window. Like, the solution would be fine, but there's no solution. Like, maybe I can create a solution, but I don't know if it supports solutions for like non-ported packages. Because see here, like it only lets me create projects for languages, right? Like this is C++. So I don't know. Blank solution. What? Okay, so what if we open this shit? The solution viewer work now? Folder view. There. There we fucking go. Alright.
Camera file.
Because now we can make new files here and stuff. Like now I don't have to go and manually do it in Windows.
All of the player logic into its own player file, and then maybe like the
And does it feel better to have this on the left or on the right? I think maybe it's nicer on the right. It's hard to say. I think on the right is better.
the light and the floor. We'll put that into like a world file or something like that. So, all right. So to begin, let's start with the player, and to do this, let's first create a new player RS file, and then I'm going to grab this code, copy it, and then I'm just going to comment it out for now. If you don't know how to comment out a large block of code, just highlight it all and then do control / and that, at least on Windows. I'm not really sure what it is on Mac.
What? What? Comment selection, which is not currently available? What? What?
It's probably very similar. And then you'll see this is airing out.
Fuck off! Jesus Christ, Dan. Maybe I should just program in Notepad++. I really don't want to do that, though. I really wanted my IntelliSense. Comment selection not currently available. Visual Studio. No, that's not what we're looking for. Tools. Options. Text editor. All languages. Oh, this is not. try this one. Visual Studio. Oh, it just works. All right, let's continue.
Because it doesn't exist in here anymore, so let's just get rid of that for now. Then in here, let's import Bevy Prelude All, and then we're gonna create our own plugin. So it's very easy if you haven't done it before. So don't think that it's gonna be difficult or anything like that. But to do that, all we need to do is create a struct first called player plugin, and then we're going to implement plugin for player plugin, and then it needs a build function here, and you'll see it's very similar to what the main function already does, but it's just moved into its own separate file here. All right, now let's go ahead and paste in that system that we copied from the main file, the spawn player system. And then we're going to add it to this build function here. So add systems, this is a startup system, and then spawn player. And that's it. That's all a plugin is right there. So now to use this plugin, we need to import it into this main system or this main file here. So mod player, and then use player plugin.
Hold on, where were we?
Plugin is right there. So now to use this plugin, and you'll see it's very own separate file from the main file, the spawn player system. And then we're going to add it to this build function here. So add systems.
Okay, so you put this here.
This is a startup system, and then spawn player. And that's it. That's all a plugin is right there. So now to use this plugin, we need to import it into this main system or this main file here. So mod player, and then use player plugin. And we're going to add it alongside of the default plugins here. So wrap the default plugins in a tuple here, and then write player plugin.
Oh, I can't tell what is his shit. Like, he's got a lot of weird things that just kind of write things.
Now, before we move on and try the other ones, let's test them one by one as we're going, so we don't go too far down a rabbit hole with incorrect code. So I'm going to run it here. It should look just like what we had at the end of the... So I'm going to run it here.
He's got two brackets here. This is a little bit weird to me. Maybe that's all. Path separator. Is that the one?
Here have a hole with other ones, and then so use this, and then
He might have written something incorrectly here, so I'm not sure. Oh, this is supposed to be app.add. Ah, that's probably it. It was capital app.
spawn player.
Seems to compile now. Yeah.
And that's it. That's all a plugin is right there. So now to use this plugin, we need to import it into this main system or this main file here. So mod player, and then use player plugin. And we're going to add it alongside of the default plugins here. So wrap the default plugins in a tuple here, and then put player plugin. Now before we move on and try the other ones, let's test them one by one as we're going, so we don't go too far down a rabbit hole with incorrect code. So I'm going to run it here, and it should look just like what we had at the end of the last tutorial. Yep, looks good. So let's move on to the next system. And now that we know this is working perfectly, we can go ahead and just get rid of that from this main function or the main file here. All right, let's take the camera next. So let's copy it. I'm going to comment it out. Then let's get rid of that non-existent system here. And then let's create a new file called camera.rs. And very similar to the player plugin, we can actually copy this. That'd actually make it pretty easy. Let's go ahead and copy that, paste it in here, but instead of calling this player plugin you guessed it, we're calling it camera plugin. And we can call this spawn camera. And then down below, just go ahead and paste in what you copied earlier. Let's see. There we go. Alright, and if you didn't know how I did that, by the way, if you want to look at your history of your clipboard history, so things that you've copied up to maybe like 20 items, if you hit Windows key V, you can go through and look at all the things that you've copied. So there's quite a few options. I definitely use that on a daily basis. Alright, back over to the, since we got this camera plugin created, let's go over to the main system, or main file here, and go ahead and add the camera plugin. But I need to first import it. Alright, again, let's go ahead and do a proof of life test. Looks good. So we can get rid of that now. And then we're going to do it one more time with the spawn floor and spawn light systems both together here. So I can actually comment that out as well. And I'm going to call this world.rs. And go ahead and I'm going to copy those in first this time. And then we can go over to the player plugin here and copy this straight from here because it's going to be very similar. Work smarter, not harder. And this time we're going to add a tuple with two systems in here, so spawn light and spawn floor. And we also need to rename this to, excuse me, world plugin. Alright, we got that situated, so let's import this plugin into the main file and main system here. Okay, so now we got all three of our custom plugins put into the main system. Let's run it one last time to make sure we're still running everything correctly. And we are. Looks exactly how we left it on the first tutorial, so that's just what we want. Now we can go ahead and get rid of this commented out code from the main file here. And now your main file looks nice and clean, and you have your code broken down. So if you need to add something, some player functionality, we'll just add it right here in the player file. If we need to add something for the camera functionality, just add it to the camera file. So this makes it a lot better as you go forward and as your projects get more complex. I highly recommend breaking your code down. This is a very simple way to break it down too. There's more complex ways to do this that make more sense as your project grows, but we're not covering that in this video. Alright, thank you for watching. I'll see you in tutorial 3.
Okay.
Okay, in this tutorial, we're going to add movement controls to the player object, and it's pretty simple. First, we need to create a player component. And I think that needs to be capitalized. Oh my gosh. That was a struggle. Okay. We have our player.
I don't have IntelliSense still. Okay, so what if we do it this way? Oh, it doesn't come with Rust Analyzer? You have to install Rust Analyzer separately? Oh! Why is everything so dog shit? Oh fuck, I hate programming. Oh my god. What are you doing? Did I miss something? Am I retarded? Is it because I made a solution? Okay, so let's do that. And then we go and we delete the solution file and the VS file folder. Holy shit! I don't think I've ever installed or done anything programming wise that was ever as straightforward as the instructions. The instructions never work. They're never complete. Not even once. It's just like, just download it and just use it. And then you actually need like 7 steps to figure out how to actually use it. Oh boy. Does it work now? Rust Analyzer is not properly installed. How is it not properly installed? And the install button doesn't do anything. Last time it didn't do anything. What did that do? Did that do anything? Huh? Is that all I need to do? Just click install? Just like create a file or some bullshit? Why does my keyboard not work? Why did it break my keyboard? How did it break my keyboard? How did it fucking break my keyboard? Are you fucking kidding me? What the fuck? How'd you break my keyboard? What is this fucking bullshit? Fuck you. This is like the worst fucking plugin I've ever seen in my entire life. Like, are you kidding me? Oh, fuck yourself. How'd you disable my keyboard? How'd you write a fucking plugin that disables my fucking keyboard? What is wrong with you? Get started. Just open the fucking thing. It's easy. Just do it. Just open it. And then IntelliSense just works. It doesn't, like, even if this is something I have to do, I have to, like, press the install button. Even if that is something I have to do, it's not a part of the install instructions. So why doesn't it work? It just doesn't work. It's just fucking garbage. Let's try reinstalling this piece of shit. Let's delete the VS file again. Maybe that's what's doing it. Maybe I fucked it up by doing that. Who the fuck knows? Right. Let's try again. You fucking bitch. You fucking dumb bitch. No, it's still doing it. What if I hit the install button? And then we try again? Like, does that create something? Like, it doesn't say what it does. Does that create something here? No. It doesn't work, you dumb bitch. Oh, I'm so tired of fucking garbage. Oh, now it works? What does this mean? Oh, you deleted the error when I clicked the thing? Okay, you fucking moron, retard. Yeah, where's the error? Where's the error, you stupid bastard bitch? Dumb bitch. No error, no error, no error, nothing. Holy shit. Everybody sucks at fucking everything, I swear to God. What is it saying? Activating language client Rust. Your task failed with the message. The JSON RPC connection with the remote party was lost before the request could be complete. What the fuck does that mean? Okay. Let's try clearing the cache. Yes. You fucking dumb bitch. Okay, hold on. We went too fast. I'm gonna regret doing this, but hey. new ton. Okay. We are uninstalling this piece of shit. We'll deal with it some other fucking time. Let's try only using the analyzer. This is obviously garbage. Doesn't have any autocomplete, but hey, whatever. I guess. Oh my god.
Player component. And then we need to
There. 1-star review. Just tanked it from 5 stars down to 3.5. Back to me and I'll fix it. Alright, let's continue before I fucking maul it out of my ass. So what are we doing? We're in player. Derive a component. Rocked player.
System, and I'm gonna call this system player movement, and we need quite a few different parameters on this movement system.
Is that a struct? Are you fucking shitting me? Are these people you completely retarded? Do I need a full screen help section every time I hover over a fucking struct? I'm gonna fucking blow my fucking brains out. You fucking dumb bitch. Holy shit. Holy fuck. This is such garbage. Let's try the third one. Maybe that one's made by someone who isn't a fucking moron. Holy fucking shit, dude. All I want is autocomplete. Literally the only thing I'm asking for here. God damn. Oh, this one doesn't work at all. That's cool. Okay, what do you want me to do then? That's what I just installed. You cunty piece of shit bastard. You fucking bitch. You stupid fucking bastard. Is this the one I was using? Yeah. And now it has gutted the basic coloration that was there before. Thank you. You fucking dumb bitch retard. Hello Grog, how oxidized iron go? It was going fine, but then I tried installing like some packages to help make the programming nicer, and they all just fucking sucked ass and didn't work and like broke Visual Studio. So now it's not going so well anymore, and I'm fucking angry. Let's see if that fixes the coloration again. No? Okay, that's cool. That's so fucking cool. I'm so fucking happy, bro. Alright, so what do I do now? You dumb piece of shit. Try deleting the VS folder. There we go. Honestly though, I don't regret giving these 1 star. Like, if you don't have any install instructions or usage instructions at all, and it doesn't work by just clicking download and installing, then you're fucking trash. Like, you're just garbage. Like, I absolutely despise anything programming related that's just like, it's just a download button and then all it has is like principles, features, this is what it does, and then you click download and install it and it does nothing. Like, what am I supposed to do with that? Like, am I supposed to, like, maybe I was just supposed to delete the VS folder again? Like, maybe that's what I needed to do? Let's try installing source key or Rust again. One more try. Maybe it's too dogshit to actually update the files in the .vs. And it needs to do it from scratch, despite it not saying that or anything at all. Let's see what happens. You fucking dumb bastard. No, it still doesn't work. Rust analyzer not properly installed. What am I supposed to do with that? Like, are you stupid? Like, you are stupid. What do you want me to do? Special place in hell for programmers. I am presiding over it. A lot of people, I see people complain about like managing libraries and stuff like that in when it comes to programming. And in reality, it has nothing to do with managing libraries. It's just that programmers are fucking retarded. And not even programmers can understand what the fuck to do with programmers' stuff. So garbage. They all have some fucking autistic, super specific way to just do everything. Yeah, it's incompatible. Do I want to disable it? No. But that disables the other one. So like, what am I supposed to do? Is Rust Analyzer supposed to be installed but disabled? Like, nothing makes any sense. It just doesn't work. No, it's not properly installed. This one is called... Let's see if I can update. Force Gear. Force Gear Rust. There. Then we uninstall this garbage again. Uninstall this garbage. And then we continue with the tutorial without anything. Fucking dog shit. I swear to God.
interesting is the ability.
All right. Are we back to normal? Yeah. Fuck.
So first we need the keys resource, and this is going to be in control of gathering that input from your keyboard. And then we need the time resource, which we need to access the delta.
What did I have? Like, what was I doing? What did I install to get commenting to work? Holy shit, why is this so fucking tedious? Oh my fucking god, dude. I should just install VS Code instead. God damn, dude. Alright. No, the Rust Analyzer didn't work, because it yielded an error here. It's retarded. Its extension assumes you have already installed Rust Analyzer. It looks for Rust Analyzer on your path. Oh, is that it? You need to install this in some fucking way? That was like super obvious to some fucking dumbass? Okay, sure. Why not? Rust Analyzer. Fucking dumb bitch. Wait, that's not all. Is the one? No? Rust Analyzer, unknown, PC, Windows. I guess. Rustanalyzer.exe. Rust Analyzer. Then we go to system. It's like when they write instructions, install instructions, they're already assuming that everybody has been using like this for like 10 years or whatever. And they're like, everybody knows how to do that. I don't need to write that, because they're programmers and they have absolutely no fucking clue how to think of like how anybody else thinks at all. Like they only know how to think in their own little autistic ways. It makes me so fucking angry, dude. Absolutely cannot tolerate this bullshit. Fucking dumb bitch. Okay. Let's try Source Gear again. Is that gonna work now? Is that all it's doing? It's just checking for that in your path? In that case, that's a much deserved 1-star. Fucking dumb bitch. Goddamn asshole. No. What the fuck are you talking about? Enter key doesn't work anymore. Maybe I need to run VS as administrator for it to be able to install, because it's fucking retarded. Nope. No, it just doesn't work. It's just broken. I know, I have to start it again. Then try installing the other one. Fucking dumb bitch. Wasting my entire fucking Saturday with this fucking bullshit. Fuck you. Dumb fucking asshole. Commenting still doesn't work. Oh. You actually get something here. Whew. However, commenting doesn't work. How the fuck do we do that? You fucking asshole. It doesn't add rust here, so... What the fuck is this then? Okay, there we go. It's not right, but it works better. Slightly better. At least we can comment out things now. Oh my god. I'll try to set it up in VS Code later. See if that works better. Because I think Visual Studio is a little bit it's a little bit too specialized, right? For the languages that it has. And it seems like these packages are total dog shit, so it might be better to just go with VS Code instead. If those packages work slightly better. I don't know what you're missing out on with VS Code, because I've never tried using VS Code instead of Visual Studio. But it can't be worse than what I had to suffer through here. Anyway.
From the time resource, which essentially is the time in between frames. So you multiply that by the movement of your player, and it'll create a smoother movement. If you don't use the delta, I believe it'll be very choppy. And then we need to write a query for the player. And we need to access the transform of the player. And what this is on the right hand side is a filter. So if we didn't have that here, our code would not compile because it wouldn't know what transform to get. There's plenty of different transforms. There's a transform for the light object that we created. There's a transform for the floor that we created and the camera. So we need to be specific about what transform we are querying for. Also, personal preference. When I write a query, I like to write the type of query that I'm filtering for, which is a player.
I don't know what that is.
Underscore Q for query. So that's just what I like to do. And this actually brings me to a good point. Before we continue on with the system, we need to add this player component to the player object that we spawned in the system below. So down here, we first need to wrap this player variable in a tuple. And then down here, do a comma.
What the fuck? Where are we? Here?
Let's go ahead and clean that up a little bit. A comma, and then put player in there. Let's see. This is messy looking. Let me fix this for just a second here. There we go. Alright, no, I did something wrong here. Oh, no, I didn't. It's just an error because I haven't finished the system above it. Okay, now that we got that, we need one more query, and that is the camera query. I'm going to call it cam_q. And with this one, we need the transform as well, but we don't need mutable access, so no mute keyword required. And then we're going to wrap the filters in a tuple because there's going to be two filters here. We need
tuple,
width, which we're querying for the transform with the camera 3D component. and this is going to be without the player component. So let's see here. I believe because in this same system we're already querying for transforms in another query, we need to specify in one of these a without filter as well. So I decided to do it just in the camera query, but we're querying for the transform of the camera 3D component, and we're also being specific that it is not with the player component. I believe you will also get some type of conflict error if you don't specify this without filter. All right, those are the parameters that we need to write the system. And let's begin writing the system. All right, I'm going to iterate through these queries, or the player query, with a for statement. So I'm gonna write for player transform. Actually, I don't need the tuple, so I'm gonna get rid of the tuple. Player transform in player q dot intermute, and then now I'm gonna grab access to that camera. I'm gonna call it.
Yo, what the fuck? Goddamn plugins keeps adding like a million text items. Holy shit. Types it like that. Is this a for each? You just do for each like this?
So I'm gonna write a match statement just for some light error handling here. So if okay, we're gonna return the camera. If not, let's go ahead and print out an error message here.
Did you fucking autocomplete some goddamn dog shit?
Those should be curly brackets or curly braces, not square brackets.
What?
Okay.
Oh, yeah. My monitor is too small.
Those should be curly brackets or curly braces, not square brackets. Okay, now first we're going to create an empty vector. We're just going to call it direction. This is going to be the direction that the player is moving. And then here we're going to calculate the direction in which the player is moving. So I'm going to write some comments here to describe in which direction the player is moving. And that is a spelling error over there. So if
it was unwrapped.
Pressed, this is where that key resource is coming in handy. Keycode.w we're going to add the forward direction of the camera using cam.forward. So this makes it really easy. And we're just going to do this for the left, right, and back directions as well. Alright, now let's do the back. If keys.pressed, key code, what is back? S direction plus equals cam.back. Now let's do left and then right. If keys.pressed, key code A, direction plus equals cam.left. Then one more here. If keys.pressed, plus equals cam.right. And I don't want the Y value, so the up and down in our case, to change for the movement. And I'm gonna leave it for now, that way you can see what I'm talking about, and then we'll come back and correct. So disregard what I was saying. Alright, let me write something out real quick and then I'll explain it. Oh, we did not write player transform as mutable. Okay, so on line 48 here, we're creating a new movement vector, and we're taking the direction that we calculated in the left, right, back, forward directions, and we're normalizing it. So that's basically reducing its value to 1. That way, whether you're moving diagonally or up or back or left or right or diagonally left, diagonally back, right, it will all be a constant speed. If you didn't have this normalize or 0 function right here, if you didn't...
Let me start installing VS Code actually. You're gonna install it into the fucking app data. I absolutely fucking hate modern trash. Yeah, don't put it there. Put it in my fucking program files folder, you stupid bastard. Access denied. Oh, you can't add it there? So I have to do it as admin or something? Because Windows is fucking garbage. What kind of dumbass fucking program? It's not meant to be run as an admin. Download the system installer instead. Okay, fuck you. Damn, everything's so dogshit. System installer, there, fuck you. What the fuck? Yes, put it there. Into the non-retarded folder. That was it. This works. Somehow it has Rust support. Extensions for Rust. Rust syntax. Okay. $75,000 installs, 0 reviews. Okay. Yes. This one has 5 reviews. What did I just install? What does it fucking do? Hello, Remitter. How's it going? Where did my Holy fucking shit. Learning Rust? I'm trying to. Right now I'm just fighting extensions. Hello, Peter. So how the fuck do these things work? Like, not a single extension works. They're just all fucking garbage. Goddamn fucking pieces of shit. Does it work now? Oh, finally! It just took 5,000 years before it started doing anything. Oh my fucking god. I've wasted like a fucking hour trying to get this piece of shit to work. What is NeoVim? Vim-based text editor. I have no idea what that is. Alright, I'll download it and fuck around with it later. Holy fucking shit. Alright. Maybe now we can do something. I was using Visual Studio before, and Visual Studio wouldn't let you hit KC to comment out a selection for Rust, because it's like, nah, we don't understand this language. So I tried installing the Rust analyzer extension, didn't fucking work, and it was dog shit. And then I tried installing the other packages, none of them fucking works. Holy shit. Visual Studio, yeah, I'm coming straight from Unity development. I'm not used to this kind of stuff. I've only been developing in Unity for like 10 years. I've always hated dealing with like other programmers' stuff, meaning like extensions and everything and their documentation. So I really, really hate this. That's why I liked working in Unity, because it was very little of that. But it seems to work now, so there's a terminal here, right? I understand Windows is more popular for game dev. Well, I wouldn't say that, but it's just like, it's not like it's an active choice to work in Windows. It's just that everybody uses Windows. So like very, very small amounts of people actually work with Linux, like actively, just because it's just, you have to feel like you have a reason to use Linux in the first place. I don't feel like I have a real reason. In fact, it just feels annoying. I would like to use it, but it just can't be arsed. Anyhow. This seems to kind of work now, so... I mean, I hate Windows. I hate Windows 10. I didn't even like Windows 7. So... eventually I do want to work, or I do want to use Linux more, but there's just too many annoying factors, so I just don't want to. So I'm just following this video tutorial right here, right now. Let's see, did I forget to save? Save that. Save that. And we can close Visual Studio. Back to VS Code. And I guess we just reopen. There. And we'll see. Wish you success. Followed. See you later. Alright, dude. Thanks for dropping by.
Normalize your new direction. if you were going up and right at the same time, so you're going diagonally, you'd actually travel diagonally faster because you're pushing down on 2 keys. So this is basically eliminating that issue. And then 2 here, this is basically our speed multiplier. So to change your speed, you want to change this value right here. And then this is that delta that I was telling you about earlier with the time resource. This is basically bridging that gap from frame to frame and creating a smooth transition experience. And then we're assigning this new direction to the player transform dot translation. So this is essentially all we need. We're going to modify a couple things, but we should be able to plug this into our systems and...
It's iter underscore move. And yeah, now I'm getting the exact same bullshit pop-ups that he is getting, which is good, I guess. And it looks the same.
Go ahead and add this to our systems, and we're going to add it to a new one because this is going to be an update system. So it's going to run on every single frame, not just the startup. All right, now we can go ahead and run this. All right, now let's move our keys.
Something is fucked up. Here? It's a curly bracket. That is not. Something is fucked up, but I can't really see where. That was fucked. I think I've written that there. That was it. No? But that was an error. All of these things have been really making it really hard to follow the tutorial. Is there a comma at the end here? Maybe it doesn't matter.
Vector. We're just going to call it direction. This is going to be the direction that the player is.
Is it this?
And then here we're going to calculate the direction in which the player is moving. So I'm going to write some comments here to describe in which direction the player is moving.
Wait, no.
And that is a spelling error over there.
There it is. God damn. God damn. But we're not done yet. It's still broken. What else is fucked up?
.w.
This is so weird. Unclosed delimiter. But it's right there. Maybe he's forgotten to do it, but his seemed to run, didn't it?
So this makes in our okay. So on line actions, or this to our to plug this in. Oh, let's go because this is going to be an up, not just. All right, now we can go ahead and run this.
Does this run? It runs.
Alright, now let's move our keys. And great. Okay, you can see that it's moving forward. But now you can see that all we need. We're gonna frame to frame. And creating a smooth. If you didn't normalize sections, and we're now I don't want dot direct.
There's just some syntax issue here. I don't see it. Do I need... Is there a curly bracket here that's missing? No?
Comments here to in which the player is.
Is it this? No? Let's look at the source code. This doesn't fucking work, dude. I'm gonna... Oh my god. Oh my god, bro. Ho ho ho. Is that it? How is that the issue? Is it... No, that looks exactly the same. But this doesn't bitch now. Oh, it's gone now? I don't even know what we did. But it's gone now. Alright.
Moving. So I'm gonna write some comments here to describe and so this is all we need. Okay, you can in our case, it's a little bit angled down, right? So it's going down. And then same thing going back. It's angled down, so it's going to travel up. We don't want the Y value to change at all. We want to give it a sense of gravity. So to do that, I'm going to, it's very easy. All I'm going to do is before I make any of these, before I modify the current player transform, I'm going to make the y value 0. So direction.y is 0. Now if we run it, you'll see that in whatever direction that I'm going, it's going to stay flush to the floor.
Yep.
All right, the last thing that I want to do in this video is having a magic number like this right here isn't ideal. We want a better way to modify that. And if we wanted to access that speed value in a different system, right now we don't have any way of doing that because we're hard coding some magic number right here. So we're going to move this value into a component, just like how the player component is up here. So let's create a new component, and we're going to call this one speed, and it's going to have a value here, a floating point value attached to it. So now inside of the spawn player system, we're going to also give it a speed of 2.0. So down here, we want to actually access that speed variable, but we need to insert that component into our player query here. So right now we're only querying for the player transform. Well, now we want to query for two things: the transform and the speed of the player. So first we need to wrap this in a tuple since there's more than one value. And we're going to grab the speed component here. And we don't need mutable access, so you can omit the mute keyword. Then same thing down here in the for statement. We're going to wrap this in a tuple, and we're also going to query for that player speed. I'm actually going to call it player speed because I like to be a little... little bit more specific about my variables.
Like that. Like that.
Now down here, instead of having a 2.0, we can say player speed dot 0. And the reason we need to put dot 0 here is because when you have a single value attached to a component here, so parentheses F32, that's how you access this single value in here. You could change it to like, let's see, value F32. So instead of accessing it like this, you would say speed dot value. But I'm just not going to do that if I only have one value associated with it. That's just a personal preference as well, but you can do whatever you'd like. Now let's go ahead and run this, and we should see the same exact results.
No, because it doesn't work. Or it's complaining.
Say speed. dot value. But I'm just not going to do that if I only have one value associated.
Maybe it compiles.
That's just a personal preference as well, but you can do whatever you'd like.
Yes, it does.
Now,
It was just bitching for no reason. I don't like that. I don't like bitching for no reason. All right.
Perfect. And just to do a proof of concept here, we can change this value to, let's say, 5, something that'll be noticeably more faster. And then if we go ahead and run it, you'll see that it should be much quicker. And it is much quicker now. So that's a much better way. You want to try to avoid using hard-coded values like that as much as possible. One, because it's easier for you to access and change it when you need to. And two, the player you can make that so the player can actually access and modify that value inside of the game. So for example, like a speed boost or something, if someone acquires a speed boost, you can increase the value of that component briefly and the player will be much faster. So alright, well that's the end of this video. I will see you in the next one.
Okay, let's go.
This video will enhance our
holy shit. I need to go to the bathroom. Oh my god. Fucking with extensions was 10 times more exhausting than doing this. Right, like by orders of magnitude. Holy shit. Fuck.
Player camera. Right now it's a stagnant camera, and I'll show you what I mean. So if we go ahead and run our current project as it were in the last video, you'll see that the player object moves around and the camera stays static. So obviously in a third-person game we want the camera to follow behind the third or the player, and also basic things like orbiting features, zooming features, and such like that. We're actually going to use an external crate for this. It's a crate that I actually created very recently, so it's the first version of it, but I think it works well for what it is, and it's very simple to use. So we're going to go ahead and create that. Also, I just realized I left the player at speed 5, so I'm going to change that down to 2.5. Okay, so with cargo, we're going to add Bevy third person camera. And then let's go ahead and run a cargo build just because we added a new crate. It's just what I always like to do. And then we need to import this new crate. So Bevy third person camera. And then we need to add the plugin here to our existing plugins. Third person person camera. No, wait, plugin. Okay, there we go. And then we need to go over to our camera system here, our spawn camera system, and we need to add a component here as well from the Bevy third person camera crate. So we're going to import the component that we need, Bevy third person camera. Actually, we'll just do all to make it easier. And then this also, since we're adding a new component to this camera entity, we need to wrap it in a tuple since there's multiple values. And this will be the Bevy, or no, third person camera component. Is that what it's called? Oh, I need to add the default features here. So default. I wrote it myself and I still don't know how to use it. Okay, so over to the player file now. And in the player file here, we need to add a target. So essentially the target that the camera needs to follow. Use Bevy third person camera, all. And then go down to the spawn player system. And then right here.
Hold on. There.
Third person camera target, just like that. And that's it. So we're going to go ahead and run our project now. And we should have a nice third person camera that has some basic features to it. So you'll see that there's an orbiting function here. And it's moving around and following the player object, which is great. It also zooms in and zooms out, and there's a default zoom bounds here, and I'll show you how to change that in a second.
Mine is different from his.
So if you hit space, it'll essentially stop the orbiting feature and unlock the cursor so that you can go ahead and hit exit or do whatever you need. And you just hit space bar for that. But it looks like my mouse highlighter still picks it up, even if it's in a locked state, but you shouldn't see that. So to unlock it, you hit space and then you go ahead and exit out. And you can also change that. You can disable that feature completely if you go ahead and look at the documentation. I just figured it'd be a nice to have inside of this. Okay, so we have a great little third person camera set up now. And if we go over to our camera, third person camera component here, let's look at some of these default components. I'm not sure why I'm not getting any IntelliSense. So I'm gonna pull this up on GitHub real quick for reference. Okay, so some of the basic features, let's fill that in with default, is mouse sensitivity. The default is 2, but I could add it to 5. Let's go ahead and run it. Yep, so now you can see it's going crazy. Get rid of that. There's also the zoom bounds, and this is a tuple that goes just like so. And there's other things like you can adjust the cursor lock feature. Like
What the fuck is this? Who the fuck are you to ask me what the fuck this is?
Anything that's supported with keyboard and mouse is also supported with gamepad, but except for the cursor lock functionality, I left that strictly for keyboard and mouse. But yeah, I encourage you to play around with it. Give me any feedback that you have on it. I hope it works well, and I'll see you in the next video.
Next video.
Hey y'all, so in the last video we finished off by adding a third-person camera crate to our project. So it should look something like this if you've been following along up to this point. Well, in this video we're going to add an actual
Thought you played Rust?
to our scene
No.
here. So instead of being a cube,
We're not playing Rust.
actual
Rust is a piece of
player
shit.
model. It'll be a little blocky figure with a guy holding a flashlight. And then we're going to add a rotation to that player object. So whenever you face a current direction or start moving in a current direction, the player model, the object, will turn and face in the direction that he's actively moving. Then we're
Player
going to
model.
finish it off by adding a little spotlight to the player, so the flashlight is actually simulating some light.
Need to download this.
Said, let's go ahead and start by adding an assets folder at the root level, so it should be right alongside your source folder. And then navigate to the link in the description, this link right here of the player model, which is a GLTF file. I'll have that in the description below. Go ahead and hit this download icon right here.
All right, we got it.
Download raw file. And I'm opening up my file explorer on the left-hand side and moving, let me exit that out, moving the GLTF file over into the assets folder here. So now we have imported our player model. Now navigate to the player.rs file and go to the spawn player system. Go ahead and comment out this PBR bundle here. We're not going to use that. And now we're not going to use these either anymore, at least for right now. And then we're going to use something else called a scene bundle. So in the scene
I'm very confused.
bundle,
Whatever.
we can actually use the same transform. So I'm going to copy that from.
All right, hold on. Player. What is he doing?
Moving. Let me exit that out. Moving the GLTF file.
He made an assets folder. Assets. Not there. Should be. Damn. God damn. Yes. And this guy goes in there.
Over into the assets folder here. So now we have imported our player model. Now navigate to the player.rs file and go to the spawn player system. Go ahead and comment out this PBR bundle.
Player. Commenting out some bullshit. This PBR bundle. Okay.
Bundle here, we're not going to use that. And now we're not going to use these either anymore, at least for right now. And then we're going to use.
Oh.
Use something else called a scene bundle. So in the scene bundle, we can actually use the same transform. So I'm going to copy that from the PBR bundle. And then I'm going to fill it in with the rest of the default parameters. And then in the beginning, I'm going to add another parameter called scene. And then this.
Copy this. That in there.
This is going to be, I'm going to use the assets resource to load the player model that we just imported. So to do that, we actually need to add a different parameter to our system, and this is going to be the assets resource. So I like to call mine assets. It's actually like the asset server, but I like to call mine assets, and then res asset.
Here.
Server, just like so. And then go back down into the scene parameter value here and write assets dot load player dot GLTF hashtag scene capital S 0. Honestly, I don't know why you have to do this. If you do know, please let me know in the description. I've just never looked into it. I just know that it's required. And also you'll notice that I didn't pass in the name of the assets folder here. Well, that's because the assets resource automatically looks at the root level into an assets folder. So you don't need to specify the assets folder. In fact, I think that would error out and it would say folder not found or file not found. Okay, so now that we have the player model loaded, let's go ahead and run this and see if we actually have correctly loaded it in. And there you go. You see our little player model here. And now you'll see what I mean by he's not actually turning and facing the direction that he's moving, so he's just staying in one area. And we're going to fix that right now.
So,
and now that I know that this works, I'm going to go ahead and delete these comments here. And then scroll down to your player movement system, go to the bottom of it, and we're going to add a little check here. Actually, not right there, right in here. We're going to add a check here to see if the player has moved. And we're going to do this. Actually, let me write a little description. Rotate player to face direction he is currently moving. And then I'm going to say if direction.length squared is greater than 0, and this is just checking if he's actually has moved at all. And if he has, then we're going to rotate the player transform with the look to function. And we're going to look to the direction, look in the direction of the direction vector. And then we don't want to modify the y value, so we're just going to pass in, actually no, what does this do? Look to direction, the up. We don't want to modify that, so we're just going to pass in vec3y. And now if we go ahead and run this, we should see a correct movement here. So I'm aiming in a different direction, and if I hit forward, boom, he rotates in that direction, rotates in that direction, rotates in that direction. Perfect. And if I hold it down and move, you'll see that he's doing that. Or left, right, back, just play around with it. And then, yeah, so that's exactly what we want. Now to finish this video off,
I don't like that. Why does it show an error until I save?
let's go ahead and add a little spotlight to that little flashlight that he's holding. So to do that, we're going to create another variable up here, and we're going to say let flashlight equals spotlight bundle, and we're just going to pass in the default parameters for now. And then down here, this might look a little bit weird, but we're going to write commands right after the commands.spawn statement. We're going to say dot with children, and then this is going to be a little closure here. I'm just going to call it parent, and then we're going to say parent dot spawn flashlight. So what this is doing, it's giving the flashlight entity the same transform as its parent, which in this case is the player. So everything is relative to the player entity. So now if we run this, you're going to see that we have a little light in the front there. It's a little bit vague. You can't see it super well, but you should be able to see it. And then you'll see that it just travels along with the player perfectly, kind of right where that flashlight is too. So it looks pretty good even with the default parameters, but we will mess around with this in the next video. So yeah, thanks for watching. I will see you soon. Hey y'all, so in this video, we're just going to be modifying some of the existing light source entities in our scene. For example, we're going to modify some of the properties on the flashlight light source as well as our main light source, which I guess is all of our light sources. So as of right now, if we want to make a change to something, for example, let's go to the world.rs file and look at our main light source. Down here in the point light bundle here, we'd have to maybe change the intensity here, and then we'd have to go back down and run cargo R and look at the changes, see if it's what we wanted. If it's not, we'd have to come back and then change the intensity. Well, there's a much better way to do this, because this way is very disruptive and breaks up your workflow a lot and slows you down. There is a crate that allows you to change all these entities and these entity properties while you are running your program and looking at your different looking at your scene.
Wait, hold on.
Hey y'all, so in the last video we finished off by
We didn't write the lights, did we?
GLTF file. This PBR bundle here, you can actually bundle. Beginning I added, never looked in, and so he's that I know that down to your player movement system, go to here, modify. So I'm aiming in a different holding. So to do spotlight here, this might look a little bit weird, but we're gonna write transform as its parent, that it just travels along with the player perfectly. Hey y'all, so in this video, we're just gonna hit the world.rs file and look at our main light source. Down here in the point light bundle here, we'd have to
there it is.
maybe change the intensity here, and then we'd have to go back down and run cargo R and look at the changes, see if it's what we wanted. If it's not, we'd have to come back and then change the intensity. Well, there's a much better way to do this, because this way is very disruptive and breaks up your workflow a lot and slows you down. There is a crate that allows you to change all these entities and these entity properties while you are running your program and looking at your different looking at your scene. So this is called the Bevy Inspector E GUI. So let's go ahead and add that to our project. So run Bevy add, or no, sorry, cargo add Bevy Inspector E GUI. And I'm gonna go ahead and build while we're waiting. And then we can go ahead and go to the main.rs file and fill out some boilerplate code. So first we need to import this new plugin. So let's go ahead and use Bevy Inspect.
Holy shit! Oh, he restructured some of the code there.
Inspector, that's not how you spell it. Inspector E GUI quick world inspector plugin, and then go down to your plugins and add it right here, and it's called the world inspector plugin, just like so. So now if we go ahead and run the project, you're going to see this new window that's part of the application, and you'll see what I mean in just a second. All right, so now you see this window here, and you can see there's a lot of just generic names here. So we don't see anything to do with a player, but I think that's this one right here is entity, and then the ground is probably this PBR mesh. The point light is probably our main light source. So that's not a very good way to be able to identify which entities are which through this world inspector. So we can actually change that and be able to so we can access these very easily. Let's go to the player.rs file, go to the spawn player system, and we're going to add a new component to this system. And we're going to say name new player. Let's also add it to the flashlight entity. So first we need to wrap this in a tuple since there's going to be multiple components. And we'll call this flashlight. And let's do it in a couple different areas. Let's go to the world.rs file. Let's go to the floor, and we need to also wrap this in a tuple if we're going to add another component.
On floor.
And we'll call this one on floor or ground, whatever you want. And then also down at this main light source.
There. I kind of hate this convention. Having the bracket there and then goes down. I really dislike it. I prefer it when it's like this so that you can see where they both intersect properly. I think it gets like cluttered otherwise. Like I can't tell what's part of what in his code.
Going to again wrap it in a tuple. Right.
See here, it's like where is what? Like, okay. We do that. There now. That feels like it makes a lot more sense. And now this needs to be wrapped. So dastardly. Yeah, I know. Right.
Name new main light.
Main light.
Or there you go, just like that.
Oh boy!
So now if we go ahead and run this project, you're going to see in this world inspector, we have some names that make sense here. So here's our main light. And we want to modify some of the properties on here, and I'll show you how to do that. So if you go to the main light drop down and then go to point light, here's a bunch of properties that we can change. And if we
This is good. This is honestly what I was worried. Like, this is what I was the most worried about losing from Unity.
So the spawn light system, here's that point light bundle. And here's the intensity that we have set to 2000 right here.
Because so programming this is a pain in the ass.
Smaller, like 500. Okay, that looks a little better, but let's make it a little bit darker and put it at 100. And I think that looks much better. It looks like it's actually nighttime. But now let's change the color.
Yeah,
So
you have no idea how much I was swearing earlier, dude.
is kind of like an orangish hue, maybe at dusk time or something like that.
Shit.
So I'm going to change this. I think that looks pretty good for our purposes. And now that we have, actually we want shadows enabled too. So let's go ahead and add these shadows. So now there's a shadow on my player. You know what? I actually don't like that. So I'm going to take the shadows off of the main light source. But now we can go ahead and mimic these same properties over here while we have them up. So let's put the intensity at 100. And then you'll see these RGBA values right here for the color. Go ahead and hit the copy button. And then now we can close out our game window. And I'm going to paste those in there for now. And we need to add a color source here. Color RGBA. And we can't just add 255 or 199 like that because this is expecting a value from 0 to 1. So we need to convert these. And how we do that is we divide each one of them by 255. So this first one's easy. 255 divided by itself is 1. And then now we need to do 199. I'm going to do it in my terminal here. Divided by 255. That gives us 0.78. 0.78. 0, that's easy. It's going to be 0.
You can't just do the division here? I mean, sure, I guess. You want the numbers to just be...
So now if we run it, let's go ahead and just verify that it looks like how we just had it, modifying it through the world inspector. And it does. So perfect. Now we're going to modify the actual spotlight of the flashlight. And this is going to be under player. And then remember, we spawned this flashlight as a child of the player entity. So it's going to be under children here. And then here you're going to see the flashlight entity. And then go down to spotlight, and this is where you're going to find all those properties. And we're going to modify some of these to make it look a little bit better. So first, let's change the color. I'm going to make it kind of a yellowish hue to be more of a flashlight. And I'm going to copy those values, and I'm going to paste them. Actually, we need to navigate over to our player RS file. I'm going to paste them up here for now, just for reference. And then let's change, I think we should add some intensity to this. So let's put 4,000 on that. And I think that looks a lot better. It's pretty bright. And then the range, I think the range is probably good. Let's leave the range. And then let's go to the outer angle. Let's see what this one does. Let's just start moving it around. Okay, yep. I want mine to be kind of like a cone shape, so I'm going to leave it relatively low, and then let's see what this does. Okay, I think this one has to be in between 0 and the outer angle, so it kind of just gives it a harder edge to it. I'm going to have it at 0.5. And now I'm going to mimic these over in the actual properties of the light source. So down here, I'll move that down over there. Down here, spotlight bundle, we're going to do this, fill in the default parameters. And then now we can actually write these down here. So color.
You do something like this.
What am I doing wrong? Oh, spotlight. Okay. Spotlight. Add the default parameters again, just to get that out of the way. And then let's do color here. Color RGBA. And then again, we're going to have to convert some stuff. So 1.0, and then Down here, we need to convert 246. Oh, I have this running, so actually let's change some other things first. I'm going to comment this out for a second, and then let's go ahead and change the intensity here. And the intensity we want at 4,000. Let's see, outer angle, we want this at 0.6. Inner angle, we want this at 0.5. I think that's all we have. So now I'm going to exit this out, and then I'm going to address the color here. So remember, I'm just doing these right here. I pasted them a little bit below. So now I need to convert 246. So 246 divided by 255 is 0.96, 0.96. And then we need to convert 95. So 95 divided by 255 is 0.37, 0.37. And then 255 divided by 255 is 1. Okay, and then I think we can get rid of that. Now let's go ahead and run our project again and make sure it looks like we just had it. Oh, no, cargo R.
The fuck are you doing?
So now that we have...
The fuck is it doing? The fuck is it doing? Okay, hold on.
Now let's go ahead and run our project.
That flashlight equals spotlight bundle spotlight default comma. You done? Yes. No? Oh, it's cause it's running. It's cause it's running. It's cause it's running. Okay.
Project again and make sure it looks like we just had it. Oh, no, cargo R. Okay, perfect. So now that we have the flashlight, actually, I think we need to modify the transform a little bit too, because look how it's lighting up the whole flashlight. I don't think we want that. So let's go back over to player, children, flashlight, and then go down to transform.
Layer, children, flashlight, transform.
And then here you'll see the transform values. So we want to modify the translation. And let's see. It's, where do I want it? I'm not actually sure. I think we'd want it like right there. So negative 0.5. So let's go over to our spawn player system again. And then let's write transform from x, y, z, 0.0, 0.0, and then negative 0.5. But I think the y value should be very small positive number, 0.2.
Well, whatever. I don't care.
actually, we want that at 0.
Okay, so then here, you need to modify the transform. Is that simply... Is that here? I'm just trying to figure it out. But that's not part of the Spotlight bundle. That's part... That's like... That's here. Transform there. Well, no. Okay, so the way you do it is...
Something like that. I don't think it's a big deal. So let's just go ahead and continue.
It goes down here. Did he remove this default? No, it's just behind. Okay. Here you type transform from XYZ from.
You on with the tutorial here. You can modify it however you'd like. But okay, so that's in a nutshell how to use the Bevy Inspector E GUI crate. So as you can see, it's a really good tool to be able to debug pretty fast and modify properties. And then you just look at those properties and copy them over to what you have in the code. So yeah, I think that's going to wrap it up for this video. I will see you in the final video, I believe. It will be in video number 7. All right, see you guys over there. Hey y'all, in this final video, we're just going to add some more objects to our scene. That way we can shine the flashlight on them. And then I'm going to show you how you can use closures to actually knock down on some repetitive code. So right now in our current state, if you've been following along, we have this simple scene right here with this player holding a flashlight and shining it around. So let's go ahead and give it some objects to actually shine upon. We're going to create a new system within the world.rs file called spawn objects. And this spawn object systems this spawn object system is going to have the same parameters as the spawn floor. So we need the meshes, the materials, and the commands. And then down here, let's go ahead and create.
Wait, what? No, that's light. On floor, that's the one we want.
Create our first object, and we'll call this blue cube. And this is going to be equal to a tuple because we want to give it a name component as well as a PBR bundle. So we're going to say PBR bundle. Go ahead and give it its default parameters. And then down here, we're going to specify the mesh, and let's just make them cubes. Mesh.add mesh from, sorry, 1 second. Okay, mesh from shape cube new, and then let's give it a size of, let's say 4.0. And then we're also gonna give it a material, so the material is the color, if you remember. And we're going to give this one a blue color. Okay, perfect. And then for the final piece, we just want to add the name component, and we're also going to name this blue cube. Make it simple. think I got some issues here. Okay, no, we're good.
Nope. Wait. No, never mind. That goes there. This is the line ending. No? Fuck off. That code, okay.
Let's go down right
Okay, so it's super random. Like sometimes he just leaves commas after things, and it seems fine. Cannot use a comma after the base struct. The base struct must always be the last field. Okay, fair enough, fair enough, fair enough.
below this, let's actually just copy this whole thing and give it a, and we're going to change it to a red cube. So we're going to have a blue cube and a red cube, and we'll change a few things here. So we'll make the red cube a little bit smaller at a size of 2 instead of 4, and then we need to change the color from blue to red, and then change the name component name from blue to red as well. Perfect. Now let's go ahead and spawn these with the commands. Spawn commands.spawn blue cube, commands.spawn red cube.
This
Now
I don't understand what this does.
Name, the system name, and then add it to our startup right here. Spawn.
Very, very confused about this. This as well, don't really understand this yet. No.
Objects. Okay, now if we go ahead and run, you'll see that we have an object in the center of the screen just because we didn't give it an actual transform. It's just using the default position. So just like we did in the last video with how we modified the flashlight and our main light using the Bevy inspector, let's go ahead and do that here as well. It's a good opportunity. So go ahead and hit the space bar to unlock your cursor. I'm going to move this off to the side. And then down here, I'm going to specify a transform for both of these cubes. So transform from x, y, z. And let's go ahead and modify the transform of the blue cube first. So go down to the blue cube, go down to transform, and then here is what we want to modify. So let's make this one have -5 and 5. So the x value will be -5, and we're going to keep the y value as is. Actually, we're going to make the y value 2. That way it kind of sits on top of the ground instead of in the middle like it is right now. And then we're going to give the z value 5. Okay, go ahead and copy that transform and add it to the red cube. And then let's go ahead and modify our red cube. So I'm going to collapse the blue cube, go to the red cube, down to transform, and then we can change this as well. So we can maybe give this a 6, maybe be 6 and -6. So 6, and then we'll have a y value of 1, and then -6 for the z value. All right, and then I'm just going to close it out and restart it to make sure that they are where I want it to be, so I didn't just validate and I didn't make any little mistakes. And yep, that's where I want them to be.
Now, if we do this, it says transform, right? So what does that... Is the transform specifically for the position, or do I type... What does it say? See, here it's like it only gets global transform, so that doesn't really translate. From scale. Okay, is that how you do it? Or do you need to include all of it? Like you do something like from XYZ with scale. Okay.
And let's look at something real quick though. So look how when I'm shining on the cube, if I go over to the side and kind of shine at an angle, there's still, the light is completely passing through the cube. That's because the shadows are not enabled for the flashlight. So let's quickly fix that. So go to the player.rs file, go down to your flashlight, and I believe it's under the spotlight right here. If I do a control space to bring up the properties that this spotlight has, you'll see shadows enabled. So I'm going to click that. And it's automatically defaulted to false. So if we hit shadows enabled true, we should see that light not passing through the object anymore. Oh, and you know what? It looks like my flashlight is, the light is actually inside the flashlight, so it's not passing through. That's a funny little error right here. So we need to go to our player entity, down to the children, down to flashlight, down to transform, and I think we just need to change one of these values very slightly. Okay, not the X value. Let's change the Z value to negative. I want it to be as close as I can, so let me try negative 0.1. Okay, that's not going to be enough. 0.2. Okay, negative 0.2. So I'm going to quickly address this. Let's go to our transform, negative 0.2. All right, I'm going to restart it real quick just to make sure that I punched in the correct values in the correct places. Okay, there we go. We're back. All right, now if we go to the corner of our cube here, now you'll see that the light is not passing through the object. That's because we enabled the shadows on the flashlight. So good thing we fixed that real quick. Okay, now let's go back over to our world.rs file and let's look at the cubes that we just spawned. So you'll notice that these two variables right here share a lot of the same code. Well, we always want to follow that dry principle of programming. Do not repeat yourself as much as possible. And since this is a lot of repetitive code, we can knock this down basically in half using, we could use a separate function if we wanted to, but we're going to use something called a closure. So to do that, first I'm going to actually, you know what I'm going to do? I'm going to leave those right there just to reference. I'm not going to comment them out or anything yet. But first let's go ahead and create a new variable that we're going to store our closure in. And this needs to be mutatable, or mutable. I'm not sure how to say that. We need to be able to mutate it. Let mute, and we'll say create cube, and then do a set of pipes. And this is where we're going to put our pass our parameters in. And then the return type of this is going to be a tuple, and it's going to be a PBR bundle and a name component. So if you look at what we currently have right here, we have a tuple of a PBR bundle and a name. So that's why the return type of the closure must be a tuple of PBR bundle and a name. So now we're going to wrap everything in a tuple, and this is where we can kind of copy this into here. But we need to understand where the differences are between the red and the blue cube, and then pass those differences in as parameters. So let's see here. The size is different between the two, so we need to have a size parameter. That's going to be of type F32. And then instead of hard coding this value here, we're going to pass in the size variable. And then what else is different here? Actually, oh, I forgot an equal sign. That's why it's giving me issues. Okay, now next, what else is different?
Here, equal sign there.
The color, right? So instead of passing the color in or hard coding the color value in, we're going to say color of type color. And then we're going to get rid of that and use the parameter instead.
Into. What the fuck does that mean?
And then it looks like our transform is also different. So what I'm going to do is I'm going to set X, Y, Z just like this. And that's going to be a tuple of F32, F32, F32. So this is going to simulate a vec3 essentially. So instead of doing that, now I'm going to write xyz.0, xyz.1, xyz, xyz.2. And then the last thing is the cube, or the string inside of the name component. So we also need to pass a string. And then right here, we'll put name. Okay, so that's looking pretty good. Now we're just going to use the commands.spawn again. Commands.spawn, but we're going to call the closure right here instead. So create.
Okay, hold on here. Then like that. No comma.
Cube. Now we need to pass in those parameters. So for the first one, the blue cube, we want to pass in 4 for the size. We want to pass in the color blue. So color blue. Then for the transform, we want to pass in a tuple of -5, 2, and 5. So -5, 2, and 5. Oops. And then we need to pass in a blue string. So blue cube. But I think this needs to be converted to a string because that is just a string reference. Okay, all right, so we've gotten the first one down. We can copy this and paste and basically just fill in the red cube values instead now. So the size of that was 2. The color is red. The XYZ values, what are the XYZ values? 6, 1, and -6. So 6, 1, and -6. And then instead of a blue cube component name, it's going to be a red. So now let's go ahead and comment this stuff out just to make sure our new stuff is working before we delete it.
Okay, so it needs to be uppercase string there.
So now let's go ahead and comment this stuff out just to make sure our new stuff is working before we delete it. Run cargo R. And there you go. So now we use the closure instead to kind of knock down on some of that code. Imagine how much code, how many lines that would save if you had to do a lot more cubes than just that, you know. But okay, so that brings us to the conclusion of this tutorial. I hope that it helped out in getting you started using 3D.
Holy fuck!
Started in 3D with the Bevy game engine. Please let me know in the comments what I could have done better, or what would you like to see in the next tutorial series. If you'd like, I could expand upon this one and get more complex. So I'd love to hear your feedback. But thanks a lot for watching. I will see you guys later.
Okay, that was a lot of stuff, and I don't understand half of this, but I am starting to get some idea, I guess. Let. Bind a value to a variable. The primary use for the let keyword is in let statements, which are used to introduce a new set of variables into the current scope as given by a pattern. This is just a var. Is that what you're saying? What does let stand for? This is so weird. What does this even do? Because here it makes sense to me, right? Like you have create cube, it's named, it does something. Let floor. But here they're like let, and it doesn't have a fucking name. So, oh no, I get it. This is two names. This is V and W. They're just doing this. This is a multi assignment. I get it. Okay. Refutable patterns. Let sum t equals v pop else panic. What does that mean? So it's like you can assign a variable, then not assign it if. What is this sum bullshit? What is this? Is that a function? Like, what is that? Oof. God damn. Prior to this chapter, we had only explicitly discussed using patterns with match and if let. But in fact, we've used patterns in other places as well, including in let statements. For example, consider the straightforward variable assignment with let. Let x equals 5. Every time you've used a let statement like this, you've been using patterns, although you might not have realized it. More formally, a let statement looks like this. Let pattern equals expression. In statements like let x equals 5 with a variable name in the pattern slot, the variable name is just a particularly simple form of a pattern. Rust compares the expression against the pattern and assigns any names it finds. So in the let x equals 5 example, x is a pattern that means bind what matches here to the variable x. Because the name x is the whole pattern, this pattern effectively means bind everything to the variable x, whatever the value is. To see the pattern matching aspect of let more clearly, consider listing 18.4, which uses a pattern with let to destructure a tuple. I mean, yeah, that makes sense, but that's a compiler error, because it doesn't have the correct amount of entries. Function parameters can also be patterns. Holy shit. Patterns come in two forms, refutable and irrefutable. Patterns that will match for any possible value passed are irrefutable. An example would be x in the statement let x equals 5, because x matches anything and therefore cannot fail to match. Patterns that can fail to match for some possible value are refutable. An example would be sum x in the expression if let sum x equals a value. Because if the value in the a value variable is none rather than sum, the sum x pattern will not match. You fucking dumbass, what does that even mean? Do I have to go back? Just because I jumped into chapter 18? If let and while expressions accept refutable and irrefutable patterns. The compiler warns against irrefutable patterns because by definition they're intended to handle possible failure. Functionality of a conditional is in its ability to perform differently depending on success or failure. In general, you shouldn't have to worry about the distinction between refutable and irrefutable patterns. However, you do need to be familiar with the concept of irrefutability so you can respond when you see it in an error message. In those cases, you'll need to change either the pattern or the construct you're using the pattern with, depending on the intended behavior of the code. Let's look at an example of what happens when we try to use a refutable pattern where Rust requires an irrefutable pattern and vice versa. Listing 18.8 shows a let statement, but for the pattern we've specified, sum x, a refutable pattern. As you might expect, this code will not compile. I don't understand what that is. Like sum x, what is that? Like what's going on there? Like what is that? Is that a function? Is that like what is it? It's just not like I don't get it. What are you showing me? I'm assuming it's a function. But why would a function... Why would you do... Why would you assign to a function like that? That wouldn't make any sense. So yeah, we're gonna have to go back and do some very basic research here. Programming a guessing game. In Rust, variables are immutable by default, meaning once we give the variable a value, the value won't change. Meeting in like an hour or so, I guess. Holy shit. Yes. See, this I find this confusing because I don't know if you can do anything else than let, right? Because to me it still makes less sense to use a variable like this that's you know, it just adjusts to whatever you put into it, compared to just having a string, right? Like this should always be a string, so I'd rather just put strings into it, or just declare it as a string, right? But maybe you can do that. We'll see, I guess. Maybe they're just doing let because it's the easiest thing to start with, or maybe the entire thing is just like that. Handling potential failure. Not expect failed to read line. One long line is difficult to read, so it's best to divide it. It's often wise to introduce a new line. Enums. Results variants are okay and error. Okay, so we're gonna have to delve a lot more into error handling. I do like literally zero error handling, by the way. Which is not good, I imagine. Rand crate. Okay. Oh, blah, 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 blah. There's a lot of blabbing going on here. Generating a random number. I think it's going to be very difficult to port things to this. I think it's possible to... obviously it's possible, but... Oh, it's gonna be a lot of work. But I do like the idea of having more control, right? Because in Unity you don't have a main. You don't have a main code loop. The only way to have a main code loop is to make one game object with an update, and then you manually call all the other updates via that game object. Which is super... it's kind of weird. I mean, that's what I'm already doing, kind of, but... I don't like the whole updating everything randomly stuff. I never was a fan of that. Now, what I'm waiting for is if else statements. So far, I haven't seen an if else statement. Seen a let else statement, but no if else. Here we've got a match. Yeah, so you need to set everything as mutable if you want to adjust it. It's fine. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of the code need to know about. Last difference is that constants may be set only to a constant expression, not the result of a value that can only be computed at runtime. Oh. This is actually something that you can kind of do it in Unity too, but there I feel like I always have to pass in the controller so that it can access things from there. So here we have a constant named 3 hours in seconds, and here they declare that it's uint. Shadowing. You can declare a new variable with the same name as a previous variable. Okay. What the fuck is this? You can just create a scope like this with nothing? Maybe you can do that in other languages too. I don't know. I've just never seen that without like an if for a while or whatever. Yeah. Whatever. Rust is a statically typed language. It must know the types of all variables at compile time. Okay, so that's what you can do. You can just type let guess colon and whatever it's supposed to be, right? But otherwise, it's always let. Let is basically just like resource binding. That's what it is. So it comes with 128-bit integers natively. That's pretty nice. Use 64-bit floats? Okay. I like this. This is really nice compared to Unity. At least I think so. I hope so. Like, you don't have to use vector 3s. You can just make a tuple. And it just works. You don't need to have a vector 4, you don't need to have a vector whatever. Raise. Yep. Oh, this is something that you couldn't do in C#, I think. I'm not sure if you could. Initialize an array to contain the same value for each element by specifying the initial value, followed by a semicolon. And then the length of the array in the square brackets is shown here. This is something I've wanted to do at some point. It's not really that necessary, but it's nice to be able to do it. There I felt like you had to do it with a for loop, but I could be wrong. Now the scary part is, I hope there are lists. Because well, there's gotta be lists, right? But in reality, I think a list is just a... It's just like... that gets resized and messed around with. I'm not really sure how it works, to be honest. There's this as well, the stack. There's something called the stack. I don't know what that is, I'll be honest. It's a thing. Some things are handled on the stack, some things are handled somewhere else. Yep, it crashes. Function. Rust code uses snake case. Fuck off, I do whatever I want. What? Actually don't like that at all. I think functions should be capitalized, because otherwise it gets kind of weird to read it, because they line up, or they become too similar with variables. I don't like that. I always capitalize them. If it's capitalized, that's a function to me. I wouldn't capitalize anything else, like never. So I don't see the issue. Like, I don't know what they're capitalizing then. Because they do have that, right? Like, where was it? No, it was like down here. Here. This here. Some value. What is this then? This isn't a function option. It's something. I don't know, it's weird. Where are we? Here. No functions. This is pretty straightforward. It's just that they're assigning the type afterwards, which is kind of weird, but whatever. Yep. Expressions. Expressions evaluate to a value. The let y equals 6 statement does not return a value, so there isn't anything for x to bind to. This is different from what happens in other languages, such as C and Ruby, where the assignment returns the value of the assignment. In those languages, you can write x equals y equals 6 and have both... Goddamn. And have both x and y have the value 6. That is not the case in Rust. Expressions evaluate to a value and make up most of the rest of the code that you'll write in Rust. Consider a math operation such as 5 plus 6, which is an expression that evaluates to the value 11. Expressions can be part of statements in listing 3.1. The 6 in the statement let y equals 6 is an expression that evaluates to the value 6. Calling a function is an expression. Calling a macro is an expression. A new scope block created with curly brackets is an expression. This expression is a block that in this case evaluates to 4. That value gets bound to y as part of the let statement. Note that the x plus 1 line doesn't have a semicolon at the end, which is unlike most of the lines you've seen so far. Expressions do not include ending semicolons. If you add a semicolon to the end of the expression, you turn it into a statement. It will then not return a value. Keep this in mind as you explore function return values and expressions next. That sounds weird. Really weird. And I guess this is so that you can't do anything after that. This is like writing return. Because the second you do this, you make an expression. Then, because you aren't placing a semicolon, you can't make another expression, right? So that's just it. And then it has to exit. So that way you can't have like 5 or 6 different variables here and then they all like try to return a value. It has to just be this at the end. It's very I don't like this at all. This is like super easy to like fuck up. That like it's when you have return, it feels a lot more explicit compared to just not having a semicolon, which is like the easiest thing in the world to miss. But hey, whatever. It's kind of weird. Functions can return values to the code that calls them. We don't name return values, but we must declare their type after an arrow. In Rust, the return value of the function is synonymous with the value of the final expression in the block of the body of a function. You can return early from a function by using the return keyword and specifying a value, but most functions return the last expression implicitly. Here's an example of a function that returns a value. 5. Okay. So I can type it as return as well, if I want to. Is that what this means as well? Because that's what that reads like. In that case, that's fine. I can just type return and it's whatever. Are no function calls, macros, or even let statements in the 5 function? Just the number 5 by itself. That's a perfectly valid function in Rust. Note that the function's return type is specified too as I32. Try running this code. The output should look like this. Yeah. Yep. Okay. Yeah, I think we all know how comments work, bro. Control flow. Oh, if else, finally. Holy shit, now it's a normal language. Now we can work with it. I've been waiting for an if else this whole time. God damn. Do they have switches? say anything about the Switch. Rust, Switch case. Match. It's called Match here. You can write ranges? That's kind of neat. You can write like this. Match number 13, 19. Equals pointer. I don't understand what that means. It means something. All right. Is there anything different between an if and an between any of this and other languages? Mm-hmm. Mm-hmm. Yeah, there's match. So is this how they are doing? You know, you can type int b equals if x equals 0, then 7 else 1. Is that how they're handling it there? Here it's just let p equals if x equals 0, 7 else 1. It's that simple, right? And here you can type I32. This is weird. I don't like this because it looks like you're assigning it to that. That's why I think it makes more sense to have the variable like this. But hey, I can live with it. It's not a big deal. Just don't think it is that intuitive. I do think C# is probably one of the best languages when it comes to just being understandable and intuitive for a normal person. It's just pretty much how it should be. Like, it's not too oversimplified either. The main issue with it is just that it has automated garbage collection, right? Otherwise, I think it's the readability is like as good as it gets. Like C++ is completely unintelligible. Loop? Okay, you can do this. That's kind of interesting. You can return from a loop and return an actual value. Okay, so you can specify which loop to break here, okay. I wonder if you have to type it like this, or if you can type it with parentheses too, so it just looks like it's a C language. Either way, it doesn't matter that much. I just find it clearer. But it's a little bit more explicit. This is something I'm a little bit concerned about, how to use a loop like it's so it functions like it does in C#. But I guess it's pretty much the same. But in reality, a while loop is probably closer to a C# for loop. Because a C# for loop is pretty much just a slightly more elaborate while loop. That's all it is. So here, a for seems more akin to a for each. It's like it seems like it's like a middle ground between a for and a for each. The only thing I'm not seeing here is that like it doesn't have an iterator, right? So you with a for loop you don't have to iterate one, like you can iterate 2 or 3 or whatever. That's why I'm saying this is more like a for each. If you want to do the other thing, then you need to use a while loop simply. Yeah. Ownership. The stack and the heap. Hmm. It's been a 5.5-hour Rust learning stream. I'm not sure I can do much more. Meeting should be soon anyway. Team meetings. At Kyle. Awaken. This is a lot of text. Okay. Yeah. Well, it is time for me to go. I don't think we'll do more Rust today, but we'll see. I don't know what else to do anyway, but who knows. I'll see you around. Bye-bye.